Welcome to Sprattronics Learning Lab. I'm Mr. Spratt, and this is week 2 of our LEGO Spike Prime robotics lessons. We're going to be building probably our first real robot this week, and that's going to be our rhinoceros. This little rhinoceros uses our hub, a couple of motors, as well as a touch sensor to do some pretty amazing things. This week, we're going to be learning how to use our movement blocks to make our motors move and for our robot to drive. We're also going to be learning how to use some control blocks in our coding, a block called wait until. And we'll make our robot start doing something and keep doing it until something different happens to it to tell our robot to change what it's doing. And we'll also be learning a little bit about these wheels and how many rotations it takes to move our robot. But before we dive into that, I have a few questions for you, a few things I want you to think about. The first one is, when you're learning how to use something new, how do you learn how to use it? When you get a new video game, how do you learn to play? When you get a new toy or a new tablet or a new electronic device, how do you learn to use it? Or maybe it's a new bicycle or skateboard. Do you read the user manual? Is that how you learn how to use your devices? For me, sometimes I do that. We recently got some new drones here at Sprattronics for a drone class. So one of the first things that I did is I looked through the user manual just to see if there was anything that I needed to figure out. We had a kid yesterday bring a drone in, and we worked on it, we fixed the drone, and I had no idea how to connect the remote control to the drone. So I had to go to the user manual. What are some other ways that you learn how to use something new? Your parents probably deal with this whenever they get a new car or a new phone. You might deal with this when you get a new computer or a new device, new headphones. A lot of times those items come with a quick start guide, something just to help you get started, some quick way to learn how to use the product. Or are you like a lot of engineers and a lot of other folks? Do you just tinker with something until you figure out how it works? Here's what we're going to do today. We're going to dive right into our robotics kit. We're going to build this rhinoceros, and we're going to start utilizing our LEGO Robotics kit. So what I'd like for you to do on your computer or on your tablet, I want you to go to the website spike.legoeducation.com. And I'm going to flash that right up here on the screen, spike.legoeducation.com. And when you go to that website, you'll see it's loading. It shows a couple of the bricks. Mine seems to be saying this might take several minutes, and there it goes. I now see this screen, select your Spike solution. I'm going to click on the side that matches the kit that I'm using today, and I'm using my Spike Prime kit, the blue kit, and that is the one that you have as well. So we're going to click on Spike Prime. Right now it has the robot on the motorcycle or on the bicycle. And here's where I want us to go. We're building our rhinoceros today. We're learning how to use our motors, learning how to code our hub, and really getting comfortable with connecting our hub to our computer. So we're going to click on Unit Plans, and we're going to scroll all the way to the bottom where it says Supplementary Lessons. Now, even if you built this robot after watching the first week's videos, go ahead and do this lesson again, because we might touch on something that you haven't even tried yet. So under Unit Plans, Supplementary Lessons, we're going to go all the way to the number 4, Going the Distance. So I'm going to click on that one. And you should be going right along with me as we go. All right, so I want you to watch this video, and this is going to show us a little bit about what we're going to be doing today. So we have 3 challenges that we're going to do. We're going to be making a robot that just drives. We're going to be trying to calculate how far it drives. And then for our final challenge, we're going to have it so it drives and then stops when it hits a wall. So we're ready to build our robot now. And while we go through these lessons, you can follow along on your computer or your tablet, and you'll see that I'm on step 2 of 7, ready to build. We're going to build this Rhino in 2 parts. The first part is the head, the second part is the body. Now, you could pause this video and just build this on your own and then fast forward to where we start coding it. Or if you're new to this and want to follow along with me, feel free to do that. So we've clicked on build, and now we're going to click on Rhino's body. This is going to give us our directions. Step 1 on almost all of our directions looks just like this, where it is showing us to put a battery inside our hub. If you did the getting started lessons last week, you've already got a battery inside your hub. There is no need to take that battery out once you've put it in, and so your hub is ready to go. So we can go on to our first step. So I see in our first step, I need 4 black Technic pieces. One thing I want you to keep an eye on and to try to do as you build, hold your hub and hold your build so it matches up with your picture. So I see there is a speaker on my hub, and I see in my picture there's a speaker on the side that all 4 of these Technic pieces are going into. And so I'm going to make sure that I do my build so that it matches the picture. A lot of times you can get away with building it a little bit different, but if we are going to troubleshoot and want to make sure it works just like it's intended to work, we want to follow the directions. I also see that I have this button on the same side as the speaker. So when I hold my hub up to my screen, I see that everything matches. I'm ready for step 2 now. I turn my hub upside down, so I'm looking at a yellow top, and I see that on one side I have my black Technic pins, but on the other side is where I'm going to attach my next piece. I also find that when I build, laying my build on a flat surface makes it a lot easier to press pieces inside of it. All right, I now need, I'm going to take it from this robot. My next piece, this is probably your first time using it, so you'll have to press that ball down into here, and that will just attach right on to our robot. I now need 6 of these Technic connector pieces, and I see that I'm still building with my robot upside down. This is step 4. And feel free to pause these steps or fast forward them if you're building faster than me, or if you don't want to listen as I build. Feel free to pause it and just skip forward in the video to once we've put the build together. All right, we're on step 5 now. The next piece that we're going to add to our build is going to be a motor. I want you to pay attention. You have 2 medium motors and 1 large motor. We're not using the large motor for this build, so that can stay in the box. You do need this medium-sized motor. And I notice in the directions, it wants me to line up the line and the open circle on the top of the motor. So I'm just going to attach that on the side closest to me, and then my cord is going to plug into spot A. And these plugs only go in one way. You'll see that one side has 2 grooves on it, and it plugs just like that. I'm on to step 6, where I see that I need to add 2 more of those black Technic pieces, Technic pins, into my motor. We're on to step 7, where we just rotate our build around. And again, we're going to add another medium-sized motor on the side closest to us. And that wire is going to plug into port B. And if you look really closely on top of your hub, you'll see that one side is labeled A, C, E, the other side B, D, F. So right now I have something plugged into A and B. taking a look at my picture and I see that my build should be upside down still. I'm going to line that circle on my motor up, and now I'm ready for 2 more Technic pins. We're on to step 9. We're going to do something called wire management now. When you're building with these robots, it's always a good idea to keep your wires under control. That is one quick way to run into a problem, is if your wire gets tangled up in your motor. So we're going to take 2 of these wire clips, as well as a tiny red axle piece, which I don't see one in my kit, but this one is missing a few pieces. And we're going to attach those together using that small red axle piece, just like that. And still, while our robot is upside down, we're going to slide the wire into both of those pieces. And that's going to hold our wires out of the way and hold them together on the back of our rhinoceros bot. We're ready to attach some wheels to our motors in step 12. And so we will need 2 of our wheels. Your kit has 4. You'll only be using 2 for this build. There we go. On to step 13. We're going to need 2 of these small yellow axles. And in step 14, we're going to be attaching these little arrow indicators to the ends of them. So there's one. Here's my other one. And I'm ready to go on to step 15, where I have my robot upside down, and I'm going to push these arrow indicators into the motor. And this will help me keep track of how many times my wheels rotate during this build. And it looks to me like step 16 shows us we're done with the rhinoceros body. So now we're ready to go to the next step, and when we click that, it takes us back to the screen where we can see the full Rhino build, and we have the choice of clicking on Rhino body or Rhino head. Well, we've already built the body, so now we're ready to build the Rhino's head. This next piece is a really neat piece. This is called a force sensor. And we will be using that for this rhinoceros to sense whether or not it has touched anything. And so in step 2, we're going to add 4 Technic pins to the rhinoceros. And then in step 3, I want to make a special note about this step. These purple pieces, we're going to use a lot over the next 12 weeks. And one side has 2 holes in it. And then if you go around to the other side, it has no holes in it. And then keep rotating and another 2. Try to match up with what the picture shows. So I see when I plug these in, I'm going to plug 2 of them in, I see that whenever I look in the front, the holes are facing the front and the back. This is going to let us, later on, plug it right into our robot. This is one of the first steps that students oftentimes attach it the wrong way, and then later on, they can't finish the build without doing a little bit of troubleshooting on their own. And that's a big part of this program, is troubleshooting our problems and figuring out how to fix things as they come up. All right, we need another small yellow axle. Here we go. And then we're going to use 2 of these tan pins that have an axle piece on the other side. We're ready for step 5 now, which is going to involve our white cylinders. And so we'll just take those out, and we're going to cover them up with a little piece with one stud on the end. And this looks like it's going to be our rhinoceros's eyes, so we will put some eyeballs or pupils onto the end of these eyes. We're going on to step 7, where we are now going to attach the eyes onto our touch sensor. So we have some eyes for our bot, and right now it has a yellow mosquito-looking nose, but we're going to cover that up with a horn. We'll use a purple block for step 8, and then in step 9, we're going to cover it with something that's going to give this robot a rhinoceros horn shape. And then to smooth things out, we just need a black round piece to go onto the end. And that'll complete our rhinoceros horn. We'll just plug that right onto the end of the yellow piece, and now we have our rhinoceros with a horn on the front. I see in step 11 is where we're going to combine both halves of our build. And so these 4 pegs here, I very carefully line all the holes up and press firmly, and it plugs right in. And then I have this touch sensor, and I'm going to go around and plug it in to port C. And so there you have it. You have built the rhinoceros today. Our very last step is just a quick diagram to see if everything is plugged in as expected. So I see in port A and B, I have my medium motors, and in port C, I have my touch sensor. We're ready to code this robot now. So now I've finished step 2 of 7, and we're going to press over and now go to step 3. It's going to prompt us to connect to our hub. This is the hardest part, I think, of our LEGO Robotics program, is figuring out the first few times how to connect your robot through Bluetooth to your computer. And so I'm going to press mine, and my robot has turned on. I know it's on because I see the heart on it, and I see that I have a green circle. We're going to press to connect the hub. And so I press that yellow button in the top left corner, and now I have a choice. What color is your power button? If you followed all the steps in week 1, you probably already updated your hub. So I can press green, already updated, and then I'm going to press open. And that's going to prompt my computer to open up a window searching for the hub. I'll press the Bluetooth button 1 time, and as soon as I press it, my hub shows up on my computer. I can click pair, and I know it's paired because this is turned solid blue. Today it's asking me for a unique name. I recently took the battery out of this one, so that could be why it's asking for this. So I'm going to call this one Sprattronics 5, SP5. You can give your hub whatever name you would like. All right, we're ready now to try to code it. And so we are going to start with some free code. We went ahead and loaded everything up so that this robot will work right away. And we want to make this robot move. So we're just going to slide the lesson out of the way by clicking on those 2 bars. And now I can see my program. This program says, when program starts, set movement motors to B plus A. Anytime we're using 2 motors for our robot, we want to tell the program which motors to use for movement. So right now, our motors are B and A. And then we have a speed, set movement speed to 50%, and then we're telling it to move forward for 10 rotations. Great, so you have your program written, and be ready to catch this robot in case it drives off your table. Sometimes it's helpful just to set it on the ground, but for demonstrations, we'll leave ours up on the table. But you go ahead and push the play button, and let's see what happens. So I see our bot is driving across the table. This time I want you to pay special attention to these little arrows on your wheels. We've told it to drive forward for 10 rotations. I want you to just watch that arrow as your robot drives. See if you can count how many times It either points straight down or straight up. Choose a location that you're just going to count every time you see it go to that point. Go ahead and try that on your own now. Excellent. How many times did you count? We can change that number by going down here where it says move forward for 10 rotations. We can make an adjustment there. If we want it to go a shorter distance, we would just lower that number. Or if you want it to go farther, you could raise that number. Let's get out some red bricks now, some of these, and these are going to be our marker. We're going to stack them on top of each other, do a little bit of balance. And for this, you may want to get out a tape measure or a measuring stick, or you can guess. A lot of times we'll just do the length of a table. And so we'll set this here and set these here, and we can just hit play and see if we can get our robot to stop before it hits the bricks. Excellent. Go ahead and set your red bricks out on your table and change your code where it says move forward for 3 rotations or 10 rotations. Change this number right here and try to get your robot to stop right before it hits your red bricks. Now don't cheat and move the red bricks where your robot stops. Instead, set your red bricks out and see how close you can get this robot to stop. Go ahead and try that on your own now. One way you could measure this is you could count how many rotations it takes for you to push your robot across the table to get there. You could use those arrow indicators to see how many rotations it would take. 1 rotation is the circumference of your wheel. So my question for you is, how many wheel rotations is it going to take for your Rhino to move as close as possible to the bricks without knocking them over? What you're doing is you're calculating how many times the circumference of the wheel fits into the distance to be traveled. Now let's give you a challenge. Let's set these bricks at a new distance away from your robot. Go pretty far. And I want you to have one chance. Give yourself just one chance to calculate how far away the robot needs to go without knocking the bricks over. You could roll your robot and count. And then set it back where you started from and change your number of rotations to try to get to the right spot where it doesn't knock your bricks over, but is close. All right, mine's pretty close. I'm probably an inch or 2 away. We've been programming how far we want our robot to go. And that's really helpful for if you have specific directions for a robot to travel. But we also want to give this robot a little bit of autonomy. And what autonomy means is the ability to drive and do something on its own. So we've used this force sensor, but we have not programmed that at all. So we're going to write a program now that is going to cause our rhinoceros to stop the second anything touches or presses on its nose. So the way we're going to do that is we're going to get rid of this move forward for 5 rotations block. And instead, we're going to tell our rhinoceros to start moving. Now, I love to experiment, so go ahead and write this code and go ahead and push play. Be ready to catch this robot before it drives off your table, or even better, you could set it on the floor. All right, I have my robot start moving forward, and it's gonna move forward forever. If it runs into a wall, it's just gonna be stuck there, and it's gonna keep trying to go. I can turn my robot off by pressing the green button or pressing the stop button on my computer. We want to program this bot so it can drive as far as it wants to go and then stop when it touches something. So we're gonna go over here to our control blocks and drag in a block that says wait until. Now there's a blank here, so wait until blank. We're gonna use our sensor. Wait until the sensor is pressed. And I see that this says sensor C, and that's where we plugged our sensor in. I can also double check that I have the right sensor by looking up at the top where it shows me I have a motor plugged into A, a motor plugged into B, and a motor plugged into C. Wait until C is pressed. Now, just adding this won't do anything because we haven't told it what to do when the C force sensor is pressed. So we're going to add this right over here to stop moving. Let's test our program. Push play, and we'll set our hand out a little ways in front of it and see what happens. Did your robot stop moving when it ran into it? Excellent. Go ahead and try this robot in some different areas. See how far you can get it to travel before it runs into something to stop. And if you want to take this lesson a little bit further, what could this robot do when it does touch something? Could you make it change directions? Could you make it back up a certain distance and then travel forward? How can you change this code using this force sensor to make your robot move a little bit further? So, this is the end of our lesson for the day. You have built the rhinoceros. You've been able to connect it with Bluetooth. We used 2 motors, so we used our pink movement blocks. You saw how to set movement motors to the 2 motors. We set the speed. Feel free to go back and change that speed, see what that does. We've told it to start moving a certain distance, and so today we were using rotations. We also used a wait until block, or a control block, to have our robot move until a certain condition happens, and then do something different. One last thing I want to show you that you may have some fun testing out. Let's drag this move forward block out here again. And we can click on rotations, and we can change that to inches, or centimeters, or seconds. Go ahead and try out some different distances for your robot. See if you can set a brick 120 inches away, about 10 feet away, and program your robot to stop at 120 inches and see if it matches up with where you set the brick. This was one of our very first robots we built together. If you have any questions, you can always call, text, or set up a live quick meeting using Zoom, and we want to help you troubleshoot any of your problems so you get the most out of this LEGO Robotics kit. Thank you, and have a great day.